This lecture is going to cover section 3.4, which is using equivalences and proofs. So for sections 3.1 to 3.3, I covered the different valid argument forms, right? There was part 1, part 2, and part 3. So now, in addition to those, we're going to use equivalences and proofs as well. And what I did, and this is posted in the module as well for chapter 3, I summarized everything in one document. So let me just share my screen with that document. Wait, hold on. Okay, so you guys can also download this, print it, whatever you want, if it's easier to have it printed and with you when you're working on the homework. So here's a summary of all the valid argument forms. So we have modus ponens, modus tollens, disjunctive syllogism, disjunctive addition, conjunctive simplification. So they're all summarized on one page. And until really you start to memorize them, not that you have to memorize them, but refer to them, but you'll just start to remember some of them without even thinking about it because, you're going to apply them enough. All right, so back to the worksheet. So the conditional equivalence, and these equivalences aren't new. We were looking at them in the previous chapter. So just a reminder, the conditional equivalence, if we have a conditional statement, P implies Q, that's equivalent to not P or Q. So sometimes it might be necessary, depending on the premises that we have in an argument, to use that equivalence. So let's look at an example. It says, construct a formal proof for the following valid arguments. So these two arguments are valid, and we want to construct a formal proof. So same process that we've been following, set up a table with your statements and your reasons. So let's look at these premises. We have 3 of them. Oftentimes, like I keep saying, whenever we have a simple statement, right, or a single letter like P, it's nice to start with that because oftentimes we could use that, with another premise, and we could apply either the valid argument forms or maybe one of these equivalences. And I see that I have a P as the left-hand side of this conditional statement. So let's start with P, right? That's a premise. That's why it's true. Just fix that. And then statement 2, we could check them off like we've been doing just so we don't, focus on them anymore because we've already showed that they were true. Then I'm going to list my second premise as, or my second statement as that first premise, right? P implies R implies S, right? So you have a conditional statement within a conditional statement. But I see that, and I'll highlight that in red, the left-hand side of this conditional is the statement, right? It's the same as the statement above it. So that's modus ponens, right? And the result, so statement 3 is going to be the right-hand side, right? So R implies S. So that's, and don't forget, we have to write that statement 2 is true because the premise, and then statement 3 is true because the modus ponens on statements 1 and 2. So I have to somehow state that that third premise, right, is true, but I need to be able to use that in conjunction or in addition to one of my 3 other statements, right, to see if we could somehow eventually get to the conclusion. But right now I have, a couple of conditional statements, but then I see I have an or statement in this third premise, and it's not R or S, right? And here I have R implies S, and I'm thinking, okay, these two look equivalent, right? Because of the conditional equivalence. So I'm going to start with that. So for statement 4, I can say, so I'm just using, let me highlight up here. the conditional equivalence, right? P implies Q is equivalent to not P or Q. So if I have R implies S, that's equivalent to not R or S by the conditional equivalence. And we're going to use CE for the conditional equivalence. So I have all the abbreviations within the definitions up there. So the conditional equivalence I'm using on statement 3. Now I have not R or S, which is the left-hand side of this conditional premise, right? So let's state this premise. So we have not R or S implies W. It's true because it's a premise. And very similar to what we had above, you see how statement 4 is the left-hand side of this conditional in statement 5, right? So again, I see the pattern for modus ponens. So the result is going to be W. And that's modus ponens on statements 4 and 5. Now we just need to show the conclusion is true. The conclusion is P and W. And I know P is true, right, from statement 1. I know W is true from statement 6. And remember that conditional, but not the conditional, the conjunctive addition, right? So if we go back over to our valid argument forms, we have the conjunctive addition, right? So if I have a statement and another statement that they're true, right? Given statements that are true, then the conjunction of the two given statements, P and Q, is also going to be true, right? So for statement 7, I could say that P and W is true because of the conjunctive addition. And that's on statements 1 and 6, and that concludes the proof. So this had, a couple of different things that we've already worked on, right? The new thing that we incorporated into this was using the conditional equivalence, but we also had modus ponens and the conjunctive addition argument form, right? So these are the things we have to look out for. All right, so let's look at this example, this next one. So let's list our statements and our reasons. So I have a conditional premise. I have two premises, a conditional and a conjunction. And I'm kind of looking for things maybe that I could use right off the bat, right? Like modus ponens or modus tollens, right? But then I would have to have either the left or the right-hand side of the conditional, right? As one of my other premises. I don't have that. But I do see P implies Q in the first premise, and then I see not P or Q, which really is equivalent to P implies Q, right? That's the conditional equivalence. So I'm thinking, let's list the first premise, or I'm sorry, the second premise, right? Because I'm going to end up rewriting not P or Q as a conditional, right? So let's start with that one. So we have not P or Q and not R, right? So that's a premise. And then so let's check it off. We don't have to use that again. And so what I was just saying is that you see how we see not P or Q, and that's equivalent to P implies Q, but I have to get it alone first in order to rewrite it as an equivalent form. But you see how we have a conjunction here. So in order for a conjunction to be true, the left and the right hand side are both true, right? So we could use the conjunctive simplification, right? So if we go back to our valid argument forms, the conjunctive simplification is when you have an end statement and we could conclude either the left-hand side or the right-hand side as also being true. So I'm going to state not P or Q as being true, and that's because of the conjunctive simplification on statement 1. And now we could say, okay, not P or Q is equivalent to P implies Q, right, from the conditional equivalence. So I'm using the conditional equivalence on statement 2. And that's the left-hand side of this first premise. So I'm going to list the first premise. So P implies Q implies R or W. So that's a premise. And I see modus ponens, right? You see how I have the left-hand side in statement 3 is the left-hand side of the conditional in statement 4. So that's the pattern for modus ponens. And my statement's going to be R or W. So that's modus ponens on statements 3 and 4. So now we have to think, okay, how can I get to the conclusion, right? Which is W or Z. We need W, right? There's no other Z in this entire argument. But I'm thinking, you see how we have W in statement 5, R or W? And then I'm looking and I see in the first statement, you see when we applied that conjunctive simplification, we stated the left-hand side as being true, right, in statement 2. We could do the same thing for the right-hand side, right? We could say that not R is true because of the conjunctive simplification, right, for statement 1. And the reason I'm doing that is because you know how I said before, well, I'm thinking, okay, if we could somehow get a W out of this, because I have W here, right? And now I have an R and a not R. So this is my disjunctive syllogism. That was the first, well, one of the first things that we learned, right? So if we look at our valid argument forms, disjunctive syllogism, right? If we have P or Q and then not P, the result is Q. If I have P or Q, and not Q, then the result in terms of the conclusion is P, right? That's going to be true. So here I have R or W and not R. So then W is going to be my next statement, which is going to be true, right? So that's the disjunctive syllogism on statements 5 and 6. And I'm halfway to this conclusion, right? And remember, if we know that a statement's true, then we could join it with a disjunction to any other simple statement we want, and we know that it's still going to be true because true or anything is true, right? And that's my disjunctive addition. So if we take a statement, we can join it using the disjunction with any other statement and it's still going to be true. And we want to join it with Z, right? So W or Z is going to be true. And that's because of the disjunctive addition. So that is on statement 7. And that concludes our argument. So let's move on to the next equivalence that we're going to visit. So we talked about contrapositive, and that was back in chapter 1. So remember the contrapositive, if we have P implies Q, the contrapositive of that is going to be not Q implies not P. So sometimes that may be helpful, right? If we could see that we have the contrapositive in front of us, we might be able to use that in a proof. So let's look at the next example. We're going to construct a formal proof for this valid argument. So let's set up our statements and our reasons. So again, what I like to do is just kind of scan the premises, right? See what I can start piecing together in terms of these valid arguments. We have a bunch of conditional statements, right? And I see that this third premise, right, is not R implies Q. And then I see the right-hand side of this first premise is not Q implies R, which is the contrapositive of not R implies Q, right? So what I'm going to do is let's list the third premise, right? So we're going to have not R implies Q, right? That's true because it's a premise. And what's equivalent to this, right, is not, but I'm going to write the contrapositive, right? Because what's equivalent to not R implies Q? Well, it's going to be not Q implies not R, which is just R, right? So all I'm doing is using my contrapositive. So statement 2 is true because of the contrapositive equivalence on statement 1. So we're going to use CP for contrapositive. Now I'm thinking I have a conditional, right, in the first premise, and I have now the negation of the right-hand side of it, right, as statement 2. So that looks like modus tollens to me, right? Because remember modus tollens, if we have P implies Q and then not Q, the conclusion is going to be not P. That's modus tollens, right? So for statement 3, I'm going to state the premise P implies not Q implies R, right? So that's a premise. That's that first premise. And you could see the pattern for modus tollens, right? The right-hand side of statement 3 in the conditional, right, is negated, right? We have the negation of that in statement 2, which is modus tollens. So we can conclude the negation of the left-hand side, or not P. So that reasoning is modus tollens on 2 and 3. So now we have one premise left to go, right? And we have to somehow arrive at W, which is my conclusion. And the right-hand side of that second premise is W. So I'm thinking modus ponens would be nice, because if I had the left-hand side to put together with that conditional, then the result would be W, right? Because remember, modus ponens is if we have P implies Q and then P, the result is Q. I have a not P, but it would be nice to have a not P or S, right? But we can do that. So in statement 5, I could say that not P or S is true because of the disjunctive addition, right? We used that in the previous proof. So we're using that on statement 4. So now I could list my second premise, not P or S implies W. And now you could see the pattern, right, for modus ponens. So my seventh statement is going to be W, right? Because, and don't forget, I always do that. We have to write premise for statement 6. And then statement 7 was a result of modus ponens on 5 and 6. And that's my conclusion. So that wraps up that argument. So it kind of helps if you kind of go through these step by step and kind of just talk your way through it. I mean, obviously you don't have to talk out loud if you don't want to. I'm doing it to be helpful because, you know, I'm teaching you how to do this and I'm lecturing. But if it helps, you could kind of, you know, talk yourself through these. And if you make a mistake, it's no big deal. Use a pencil with these, right? If you have to erase, sometimes you're going to write something down and then you're going to realize, oh, that's not going to work. But the more of these you do, the more of these argument forms you'll see. And then you'll see equivalences in there. It just takes practice. The next equivalence that we might have to use sometimes is the conditional negation. So we went over this in chapter 1. So if we negate a conditional, so let's say not P implies Q, that's equivalent to P and not Q. And we're going to use CN for the conditional negation equivalence. So let's look at this next example. Let's construct a formal proof for this valid argument. So let's set up our statements and our reasons. So I'm looking at this argument and I'm thinking, okay, I have 3 premises here. None of them are like simple statements, right? With just one letter. I have a conjunction and 2 conditionals. So I'm thinking, all right, where do I want to begin? And I see, so you see how we have this conjunction? I always look for conjunctions because I know whenever we have a conjunction or an and statement, right? The left and the right-hand side are going to be true. So we could use the disjunctive simplification, right, to state either the left-hand side or the right-hand side. And the reason I'm liking that for this one is because we could state that P is true, and then I say I have not P for the right-hand side of this third conditional, so I'm thinking modus tollens. So let's kind of start with that. So let's list P and Q or not Z. That's my first premise. And then I'm going to state that P is true, right? Because of the conjunctive simplification for statement 1. And then you never know if you're going to need the other side as well. So I would just also write the other side. It's okay if you have an extra statement in there that you showed was true, but you didn't necessarily need it for the proof. So I'm going to say, okay, Q or not Z is also true because of the conjunctive simplification of statement 1. So now I'm thinking, like I said before, modus tollens, right? So I need to state the third premise. So R implies S implies not P, right? So we have that premise. And then I'm looking now at 2 and 4, right? You see how P is the negation of the right-hand side of this conditional, which is going to be modus tollens. So that's going to be the negation of the left-hand side, not R implies S. So that was modus tollens, and we applied that to statements 2 and 4. And then now I'm looking at the negation of a conditional, right? Statement 5 says not R implies S. And that's going to be, if I negate it, right, that's going to be R and not S. So that's my conditional negation, right, on statement 5. And look what that looks exactly like. The left-hand side, right, of that second premise. So let's write down that second premise, right? So we have R and not S implies Z. That's modus ponens, right? If we look at the left-hand side of the conditional in statement 6, they're the same. So that's the pattern for modus ponens. So we can conclude Z. So that's modus ponens on statement 6 and 7. And we ultimately need to get to our conclusion, which is Q. But as I'm scanning my statements, look at statement 3. We have Q or not Z. And then if I put that together with Z, right, so this is, remember the disjunctive syllogism. If we have P or Q and not Q, that's going to be P. Very similar here. I have Q or not Z and Z, right? So the conclusion is going to be Q. And that's the conclusion of the argument, right? So we showed that that was true by the disjunctive syllogism, and that was statements 3 and 8. And we've just shown that this argument is valid using a formal proof. So let's do one more where we might have to apply the conditional negation. So set up your statements and reasons. So for this argument, we have 4 premises. Kind of a lot going on here. I have conjunctions, disjunctions, conditional statements, and my conclusion's a conjunction. So I think I'm going to start kind of how I did in the previous one. I like whenever I see a conjunction, right, to start with that. Because, so we have P and not Q implies R, right? So that's a premise. Because I can say that the left and the right-hand side are also true, right? Whether I use one or the other, right? It's okay to have an extra statement in there, even if you end up not using it. But we could say that P is true because of the conjunctive simplification of statement 1. And we could also say the right-hand side is true. So we could say not Q implies R is also true because of the conjunctive simplification for statement 1. So now I'm scanning and I'm looking at my other premises and I'm thinking, okay, is there any premise that I could use right now with one of my first 3 statements that's going to help me form another true statement, right? And I'm not seeing that exactly yet, but if you look at statement 3, it's the negation of a conditional, right? So let's negate it and write its equivalence because that might be helpful to us. So not Q implies R is the same thing or has the same value as Q and not R. They're equivalent, right? So that's my conditional negation equivalence. And I use that on statement 3. So now I have a conjunction and I know that both sides are going to be true, right? Q is true and not R is true. And I'm thinking I'm going to use not R right now, right? Because look at the second premise. I have R or not K. And if I join that with not R, right? So if I have R or not K and not R, that's our disjunctive syllogism, right? So I'm going to state in statement 5 that not R is true because it's the right-hand side of a conjunction, right? So that's my conjunctive simplification on statement 4. And I'm going to write my second premise. So statement 6 is going to be R or not K because it's a premise. And then, like I was saying, that right there that I just boxed out is the pattern for my disjunctive syllogism. So the result, the statement from that that's going to be true is not K. So that's my disjunctive syllogism on statements 5 and 6. And now that I have not K, and I see that I have a K in the right-hand side of a conditional, I'm thinking, okay, modus tollens. So I'm going to write that third statement. So B implies, or that third premise, B implies W implies K, right? It's a premise. And you see how I have the negation in 7 of the right-hand side of the conditional and 8, right? So that's modus tollens. And that's going to leave me with the negation of the left-hand side of the conditional. So not B implies W. So that's modus tollens on 7 and 8. So I'm thinking, okay, let's apply the conditional negation equivalence here. So not B implies W is equivalent to B and not W. So that's my conditional negation equivalence on statement 9. And then let's continue up here. So we have statement and then reason. You know what? Let's just call this S and R. We'll continue up here. So we're up to statement 11. So I have B and not W. And I see in this premise that we didn't use yet a not W, right? A not W or Z. So I'm thinking, okay, maybe I could use that not W. So I'm going to state that not W is true because it's part of an end statement, right? So our conjunctive simplification on statement 10 lets us say that not W is true, right? The right or the left-hand side of this conjunction, but I want to use not W because it's in that last premise. And then I could say, since not W is true, and it would be nice to have not W or Z, right? Because that's the left-hand side of that premise. I could say that not W or Z is true because of my disjunctive addition, right? On statement 11. So since not W is true, I could join it, right, with any other statement I want. It's still going to be true as a disjunction. So now not W or Z is the left-hand side of that conditional statement. So I'm thinking modus ponens, right? So let's list that premise, that last premise. So we have not W or Z. Implies S, so that's a premise. And then I could use modus ponens, right? Because 12 is the left-hand side of that conditional. So my result that's true is going to be S, right? So modus ponens on statements 12 and 13. Now, the only thing left is to show that our conclusion is true. Our conclusion is P and S. But if you look carefully at the truth, this, formal proof table, 2 states that P is true, right? And statement 14 states that S is true. So both P and S are true. So we can join them with a conjunction, right? So P and S is true because of my conjunctive addition. And that's going to be on statements 2 and 14. And that wraps up that proof because we just showed that the conclusion is true. So this was a lengthy one. Sometimes you'll see these arguments, when we do a formal proof for an argument, they have maybe 5 or 6 statements and reasons. This one had 15. It all depends. Some are easier than others. It just takes practice. So next is a reminder of De Morgan's equivalences, right? So De Morgan's is used when we're negating either a conjunction or a disjunction. So here's the negation of an and statement, right? It becomes not P or not Q. And then if we negate an or statement, that's going to be not P and not Q. And we're going to use DM for De Morgan's equivalence when we use it in a proof. So let's construct a formal proof for these next 2 valid arguments. So let's look at what we got here. So we have a conditional statement, an or statement, and then another conditional statement. And I'm trying to see if there's some sort of relationship between maybe the left or right-hand side of a conditional with one of my other premises. And I kind of see something similar, like my eyes are being drawn to this, right? The right-hand side of that conditional in the first premise is Q and not R. But then the second premise is not Q or R. So that to me is the negation. So this second premise right here is the negation of the right-hand side of that first premise. So this is what I'm going to do. So I'm going to, because it would be nice if I have them the same, right? Because if I have a statement that's Q and not R, I'm thinking, or the negation of that, I could use modus tollens. So let's start with that second premise. So let's state not Q or R. And that's equivalent to negating what end statement, right? Because De Morgan's, in order to get an or statement, we must have negated an end statement, right? So not P and Q is equivalent to not P or not Q. So then we must have negated Q and not R, right? Let me just write that again. So not Q and not R is equivalent to not Q or not R, which is R. So these two are equivalent, right? These two statements. So the reason for the truth value behind statement 2 is De Morgan's equivalent. And that was on statement 1. So statement 1 and statement 2 are equivalent by De Morgan's. But that was helpful because now look, statement 2 is the negation of the right-hand side of the conditional, right, that I have in premise 1. So I'm going to write down premise 1. So we have not P implies Q and not R. And then now I see the pattern for modus tollens, right? I have a conditional statement and another statement that's the negation of the right-hand side of the conditional, right? You see how I have a not Q and not R, and then the right-hand side of the conditional is Q and not R. So it's just the negation. So then according to modus tollens, I'm going to get not P, right? So we have to negate the left-hand side of the conditional, which is going to be P. So this was modus tollens on 2 and 3. And then now I see that P is the left-hand side of my conditional statement in my third premise. So I'm going to write the third premise, right? So P implies S and H. And now I see my pattern for modus ponens, my pattern, right, for modus ponens. So I'm going to apply modus ponens to 4 and 5, and that's going to leave me with the right-hand side, right, of my conditional S and H. So that was modus ponens on 4 and 5. My conclusion is H, and the fact that we know that S and H is true, right, and we have a conjunction, I can say that H is true by my conjunctive simplification on statement 6. And then that, ends that proof. And we just showed that H is true. So let's look at the next one. So I have 3 premises here. I have 2 conditionals and a simple statement, right? We just have not S. I always like to start with the simple statement. So I'm going to have, if there is one, so not S is true because it's a premise. And then I see the right-hand side of that first premise is just the negation of not S, right? So I'm thinking modus tollens. So let me write down my second premise. So my first one, I'm sorry. So Q or R implies S is also true because it's a premise. So that's statement 2. And then now I could apply modus tollens here, right? Because not S in statement 1 is the negation of the right-hand side of the conditional in statement 2. So that's going to leave me with the negation of the left-hand side of the conditional. So not Q or R. So that was modus tollens on statements 1 and 2. And in 3, I have the negation of an or statement. So I'm thinking De Morgan's, right? So that would leave me with, if I negate that, the equivalent statement would be not Q and not R. And I'm thinking that's going to be helpful because I have a not Q in that second premise, right? So let's apply De Morgan's. So I'm going to have not Q and not R. So that's De Morgan's equivalence on statement 3. And I want to use that not Q along with the second premise because it's the left-hand side. So we can say that not Q is true, right? Because of the conjunctive simplification in statement 4. We could say that the left-hand side of that conjunction is true. And now I'm going to state in 6 that second premise. So not Q implies W. And 5 and 6, look at that. That's modus ponens, right? Because I have in statement 5, the left-hand side of the conditional in statement 6. So we can say that the right-hand side of the conditional W is true, right? So that's modus ponens on 5 and 6. And W is my conclusion, right? So we just showed that that argument is valid. So moving along, we have 2 more equivalences in this chapter. We're going to cover distributive and then biconditional. So the distributive equivalence, remember, is if I have a conjunction with one side being an or statement, right? So let's say P and Q or R, that's equivalent to P and Q or P and R. I don't know why this keeps doing it when I'm trying to just highlight that little statement. There we go. Or if I have P or, and then a conjunction, let's say Q and R, I could write that as P or Q and P or R. So let's be on the lookout for that distributive property that we might be able to use. So let's go ahead and construct a formal proof for this example. So the argument that's in this example. So let's set up our statements and our reasons. So I'm scanning, I'm looking at my premises. I have a conditional, a disjunction, a disjunction. So far nothing's standing out at me like modus ponens or tollens or anything like that. I don't have a conjunction that I could simplify. But I do see that in my third premise, I have an disjunction where the right-hand side is also an and statement. So I'm thinking, oh, okay, I could use my distributive equivalence there, right? And maybe that'll help us. So I'm going to state R or S and W, right, as a premise. And then I'm going to use my distributive equivalence, and we're going to use DE for distributive equivalence. So we're going to have R or S and R or W. So that's my distributive equivalence on statement 1. So now I'm looking and I'm seeing, all right, I have an R or an S here, right? And then when I look at my other premises, there's a not R implies S, so same variables, right? And I'm thinking one's an or, one's a conditional, maybe the conditional equivalence, right? Because remember the conditional equivalence, if I have P implies Q, that's equivalent to not P or Q. So R or S is going to be my third statement, right? Because it's part of this conjunction here. So I know the left-hand side is true and the right-hand side is true. But I'm seeing that the left-hand side of this conditional in the first premise is equivalent to R or S. So let me just state R or S is true, right? By my conjunctive simplification of statement 2. And then I could say, okay, this is equivalent to not R implies S, right? Because of my conditional equivalence of statement 3. Right? Remember your conditional equivalence, if we have, I'll write it down here, P implies Q, right? That's equivalent to not P or Q. So I'm just applying that to 3 and 4. And now statement 4 is the left-hand side of that first premise, right? So I'm going to list the first premise. So I have not R implies S implies P, right? That's a premise. And I see 4 and 5, the pattern for modus ponens, right? Because 4 is the left-hand side of the conditional in statement 5. So the result is going to be P, right? So modus ponens on 4 and 5 tells us that P is true. Now, the only premise that I didn't use it yet is the second one, and it's a disjunction, and I have a not P. So I'm thinking, okay, maybe I could use that with 6, which is just P, right? And I'm seeing disjunctive syllogism, right? Because remember, disjunctive syllogism, if I have P or Q, and let's say not Q, then the result is going to be P. We could say that that result is true. So for statement 7, let's list C or not P, right? My premise. And we could apply now the disjunctive syllogism on 6 and 7. So we could say that C is true. And C is the conclusion. So we just proved that this argument is valid. So we have one more example, and that's going to be using the biconditional equivalence. So just a reminder, the biconditional, so P if and only if Q is equivalent to P implies Q and Q implies P. And we use BCE for biconditional equivalence. All right, so let's look at this one. So let's set up our table. So we have statement and reasons. Let's look at our argument. I see that I have a conditional premise, a biconditional premise, and then another conditional premise. And within there, I have a conjunction on the left-hand side. So there's like kind of a lot of things that we could work with, right? But right off the bat, I see that there's a biconditional. So I'm just going to write its equivalence because it might be helpful to us. So let's start with C if and only if D. So that's equivalent to if C, then D, and if D, then C. So that's my biconditional equivalence on statement 1. And now I'm looking at that and I'm thinking, okay, that's an end statement, right? In statement 2, and either the left-hand side or the right-hand side, we could state as being true. Right? Because of the conjunctive simplification. And I'm thinking I want to state that C implies D is true because look at what, and that's a conditional, right? And look what we have here for the left-hand side of the first premise, not C or D. And that's my conditional equivalence, right? C implies D is equivalent to not C or D. So I'm going to go with that route right now. So I'm going to say, okay, C implies D is true because it's the left-hand side of this conjunction, right? So that's my conjunctive simplification on statement 2. Now my conditional equivalence, right? So again, reminder, P implies Q is equivalent to not P or Q. So if I have C implies D, that's equivalent to not C or D by my conditional equivalence on statement 3. And that happens to be the left-hand side of that first premise. So I'm going to state the first premise. So we have not C or D implies not P. And now I see modus ponens, right? I see the pattern. I have in statement 4, the left-hand side of the conditional in statement 5. So that's going to let us say that not P is true. And let's not forget, this is a premise. And then we use modus ponens on 4 and 5. So now I'm looking at premise 3 because that's the only one we didn't use yet. We have to show that it's true. Well, not that we have to show that it's true, but we have to show eventually that the conclusion is true. We could state that the third premise is true, just by stating it as a premise, but I want to be able to use that in order to get to M, right? Because my conclusion is M, and I see the right-hand side of that conditional statement is M. So I'm thinking maybe modus ponens, right? If I could somehow state that the left-hand side of that conditional, not P and A, is true, then I could use modus ponens and that'll lead me to M. But I have to somehow do that with P. So I'm thinking, okay, let's look at the left-hand side of this premise. What is this equivalent to? So I'm thinking De Morgan's, right? For the left, what would be equivalent to that left-hand side? Not P and A, right? That would, so not P and A. Let's just get rid of this down here. So not P and A is equivalent to not P or not A. So if I could somehow show that not P or not A is true, and then that's equivalent to not P and A, then I could use that third premise, right? Well, look, statement 6 is not P. Can I just say, okay, not P or not A is true, right? By my disjunctive addition. If I already know not P is true, I could join anything I want to it using my disjunction. It's still going to be true. So let's join not A because that's going to help us right now, right? So this is the disjunctive addition on statement 6. And that's equivalent to not P and A, right? We just said that over here because of De Morgan's equivalence on statement 7, right? Those two are equivalent. Not P and A is the same thing as not P or not A by De Morgan's. And now 8 is the left-hand side, right? Not P and A is the left-hand side of that third premise. So let's write down that third premise, right? Not P and A implies M. And then now I see my pattern for modus ponens, right? You see how 8 is the left-hand side of the conditional in statement 9. So statement 10 is going to be M because of modus ponens on 8 and 9. And M is my conclusion, therefore wrapping up that formal proof and showing that it's valid. So in this lecture, we did a whole variety, right, of formal proofs that involve not only the valid argument forms that we learned in the previous 3 sections, but now it also incorporated these equivalences. So I know it's a lot, but my suggestion, like I said earlier, is refer to this valid argument form, right? This sheet that I made. And also from chapter 1, that sheet that I also have as a PDF of all the equivalences. So if you have these two in front of you together, it's gonna, make these a lot easier for you. And then, like I said too, you'll just start to remember some of them. Like you won't have to keep referring to the sheet. All right, so this wraps up section 3.4. In the next lecture, we will cover section 3.5.